5, 4, 13, we're going to do the same thing, except now we're taking a sample of size 50. The probability of being infected with the parasite is still 80%, so our p is still 0.8. And we want to know, find the probability. What is the probability of having 35 or fewer infected? Okay, and again, this would be easy with R. We would just do p binom 35, p equal to n equal to 50, p equal to 0.8. Or however we want. Okay, in this case, or maybe size equals 50. In this case, we want to do it with and without the continuity correction. Okay, so without the continuity correction, we would just plug in 35 for our cutoff. Okay, so we're going to use the normal approximation, and the normal approximation will be the same whether we use the continuity correction or not. So we've got to figure out the mean and the standard deviation. Our mean is going to be n times p, so in this case 50 times 0.8, which gives us 40. That's the mean number of mussels that we expect to be infected with parasites. And our standard deviation is n times p times 1 minus p. So that's going to be the square root of 8, which gives me 2.828. All right. So without the continuity correction, I'm just going to look at find my z-score and plug in 35. And I'm going to do 35 minus the mean of 40 divided by the standard deviation, 2.828. And that gives me negative 1.77. And what's the probability of being less than negative 1.77? The probability that z is less than negative 1.77. That number, looking into our table, is negative 1.77, gives me 0.0384. Alright, with the continuity correction, we just have to figure out, the question is saying probability of having 35 or fewer. No, I'm sorry, find the probability that fewer than 35. Fewer than 35. Okay, actually I need to rewrite this. Not having 35 or fewer, but having fewer than 35. Okay? And that changes things. Oh, I gotta redo this, maybe. So fewer than 35 means we do not want to include 35 in the number here. Okay? So if we have a bar centered at 35, and we have another bar centered at 34, okay, what we want to do is we want to have everything up to 34, but not including 35. So our cutoff is going to be at 34.5. Okay, and so actually going back to this one, maybe you would have chosen z is equal to 34 minus 40. Okay, and if you did that, that would also be equally acceptable. All right, and it's because we're trying to apply a continuous thing to a discrete thing, and so when you don't use the continuity correction, there's a lot of ambiguity. And in this case, 34 minus 40 divided by 2.828 will give me negative 2.12, and the z probability that the z is less than negative 2.12 ends up being pretty different. Okay, and again, not using the continuity correction will give you pretty drastically different numbers, 0.017. Okay, on the other hand, when we use the continuity correction, there's no ambiguity. We know we're going to use 34.5 because we want to include 34 but not 35, because the question says what's the probability of having fewer than 35 infected. So here again, we're going to search for z-score, and we're going to plug in 34.5 minus 40 divided by our standard deviation 2.828. And I get negative 1.94. And looking up negative 1.94, our answer is 0.0262. So the probability that z is less than or equal to negative 1.94 is equal to 0.0262. Okay? So which of these is going to be our best one? The one that's going to be the closest is going to be the one with the continuity correction. And I can actually look this up for you using R to get an exact answer. So P by Nohm and the true answer is 0.0308. So if I do P by Nohm, and actually because it's less than 35, P by Nohm 34 size equal to 50 and P equal to 0.8, the most accurate answer is going to be 0.0308. Okay, and of the answer choices, the 0.0262 is the closest one. Okay, 0.0384 is off by about 8 1,000ths. This is off by about 4 1,000ths, and this one's off by the most.